Hello everyone and welcome to Hazimet Tech channel. In the previous videos, we've explored how Python operates with variables. One standout feature of Python is its dynamic typing, which means you don't need to specify a variable's type before assigning a value to it. Python handles this behind the scenes, determining the type at runtime. While dynamic typing offers flexibility, it's important to understand its implications. Misuse of variables or incorrect types in operations can lead to runtime errors. That's why it's still important to grasp Python's various data types and the operations allowed on each one. I have categorized the Python data types as shown in this list: numeric types, sequence types, mapping type, sets types, Boolean type, and non-type. Knowing the different data types and the operations that can be performed on each one will enable you to effectively manipulate and transform data to suit your needs. There will be one video dedicated to each category, and today we will start with numeric types. First, we have integers that are whole numbers, their negative counterparts, and zero. We can check the data type of a variable using the type built-in function. Type will return the type of the argument between parentheses. So, for example, if a equals 5, we can check its type by using the type function, and we will put a between parentheses, and you can see that the class is int. That stands for integer. You can also use type directly with the value of 5 without the variable name. For example, type of 5. You press enter and it's an integer. So -4 is also an integer, as well as 0. And you may have noticed that there is no decimal point used with integers. Now, which operations can we perform on integer data types? Let's create two integer variables and call them x and y. In the previous video about naming variables, we have seen the convention of avoiding to use a single letter names for variables, except for counters and iterators. Well, we are also making an exception here. Using x and y may make us feel like we are taking a math class where x and y are used a lot as variable names. So let's create x equals 10 and y equals 8, for example. I will adjust the IDLE window a little bit. So we have two integers and we will perform some arithmetic operations on them. So we will start with the sum or the addition. So you can calculate the sum of two integers using the plus operator. We can also calculate the difference of x and y, or subtracting the value of y from the value of x. So x minus y, and enter, and the value is 2. 10 minus 8 is 2. We can calculate the product. So to multiply two integers, we use this asterisk sign, which is the multiplication operator sign, and the result is 80. And we can also perform division using the / character, or this one is the operator sign for divisions, and we press enter and the result is 1.25. So all the previous operations gave an integer result, but here it's 1.25. It has a decimal point and it's not an integer. So this is a different numeric data type, and it's called a float. If you use type of x divided by y, the class or the data type is different. It's float, standing for float data type. which we'll go in to see in a few minutes. If we'd like to have an integer result for dividing x by y, there is another operator called floor division operator. The result will be truncated, not rounded. The floor division operator's sign is two forward slashes instead of just one. And you see here the result is 1. 1.25 was truncated to 1 just to keep the integer part of the result. We can also calculate the remainder of x divided by y, and for this we will use the percentage character, and this should give us the remainder. So x is 10 divided by y, which is 8. It should give a remainder of 2. Yes, and we can negate the value of a positive integer. So x is 10, and we can negate it by preceding it with a negative, with a minus sign, and minus x will be minus 10, and if we put plus x, it will not change, and it will stay. It will still have the value of 10. So these are the basic operations we can perform on integers. There are also some built-in functions that we can use to manipulate integers. For example, the abs function that will give us the absolute value of integers. So, for example, minus 50, the absolute value will be 50. We can also calculate the power, for example, x to the power of y. So we have this built-in function called POW, and this function requires two arguments. So the first one is x and the second is y. So in this case, it will calculate x to the power of y. That means 10 to the power of 8. And the result will be 100 million. And there is an alternative way to calculate x to the power of y. So instead of using this function, you can also use another operator, which is 2 asterisks and then followed by y. So this is the same as using the function of power, and it will give us exactly the same result. So 2 ways in Python to calculate the same thing. So all these operations can be performed on floats as well. Floats or floating numbers are real numbers with a decimal point, so they are decimal values or fractional numbers. We already seen the value of 1.25. This is a float. And let's update our variables values with float values this time. So x, we will give it a value of 6.5, for example, and y equals 4.2. So this time when we check the type of x, it will be a float, and the same for y. It's a float. Let's, for example, add these two numbers like we've done previously with integers, and the result is 10.7. Now, one interesting thing to note is that when we perform operations using both integers and float together, Python ensures that the result is always a float. So even if we start with an integer and perform an operation with a float, the result will be a float. This is because Python automatically promotes the integer to a float to maintain precision and consistency in our calculations. So, for example, we will change the value of x to 5, which is an integer, and we will keep y as it is, 4.2, and we will perform some arithmetic operations. So x plus y will give us 9.2, which is a float. We can multiply these two numbers also. So x 5 times y, which is 4.2, will give us 21.0. And here you see that the result will be a float, and even if it's 0, the decimal part is 0, it will still add the decimal point and the result will be a float, because one of the two operands is a float. We can also convert integers to floats and vice versa using some built-in functions. For example, if we have x equals 10 and we want to convert it to a float, we can use the float function, and this will convert the value of x to a float. It will add the decimal dot and the decimal part, and we can do the opposite. That means converting floats to integers. So for example, we have a float y having the value of 4.2. I think it already have this value. Let's check it. Yes, it's already a float. So we want to convert it into an integer. There is another built-in function. It's called int, and we can use it to convert it to an integer, and the result will be 4. So here again you see that the original value was truncated, and in fact it will not be rounded. So let's use another example to see it clearly. For example, 4.9. So if we convert this to an integer, the result will be truncated. It will not be rounded to 5, but just truncated means that the decimal part will be removed. So the result will be 4. And the original value of y remains unchanged. So we check again y, and it still have a value of 4.9. So we have seen integers and floats. Now we will see another numeric data type, which is complex numbers. Complex numbers have a real and imaginary part, which are each a floating point number. They can be represented as follows. So for example, we can call it z, and this is real part plus the imaginary part, which is 2j, with a real part and an imaginary part. To extract these parts from a complex number, we can use z real and z imaginary. For example, if we want to have just the real part, we can use the real method, and you see here that both real parts and imaginary parts are floats also. You see here the dot 0 and z dot imaginary, it's 2.0. Other examples of imaginary numbers, for example, z equals 5 minus 7j, where the imaginary part is negative, and we can check the type of z as well, and the type is complex. And real and imaginary part can be a float as well. So for example, z equals 1.5, z equals 1.5 as real part plus 8j, and this is also complex. The real and imaginary parts can be floats as well. In fact, even integers will be converted into float. This makes sense since complex numbers can have any real number as either real or imaginary part. You can see this when you print the real and imaginary attributes of a complex number. So we can check the type of just the real part, which is z dot real, and it's a float. We can already see it since it's 1.5. But if you check the imaginary part, its type is also a float. Even if it's written 8, but it's converted into float as soon as it's a part of an imaginary number. You can also use the complex function to represent a complex number. This function will take one parameter and converts it into a complex number. For example, the complex, and we will put nothing inside the parentheses. So if we want to print the value of z, then it's 0j. So by default, it will create a complex number having real part equals 0 and imaginary part equals 0. You can use the same function to convert a string into a complex number. For example, complex 3 plus j5. And you see here we are using double quotes. That means this is a string. We'll see this data type in more details in the next videos, but for now we will see just how to convert this into a complex number. So now if we print, so now if we print z, it's just a string. But if we want, so we can check using the type function, and it's a string. If we want to convert it into a complex number, we'll just have to use the same complex function and put the string inside the parentheses. Sorry, there was a mistake. It should be 5j and not j5, and that's why we had this value error. There's only one correct syntax to write complex numbers in Python, and it should be followed to avoid such errors. So yes, 5j, and this should work now. Oh, we still have an error. This is a value error. Complex argument is malformed string. Okay, yeah, there should be something wrong in the syntax. We should use yes, the problem was the space, so we don't need to use space, and now this should be a complex number. We can also create some complex numbers using the same function, complex, and by giving it some argument. So for example, we can give it the real part and the imaginary part, and it will create a complex number for us. We can use the same function with 0. So here by default, if we just give it one value, it will create the complex number having 0 in both real parts and imaginary parts. And we can use it with any other value too, for example 5. In this case, the real part is 5, and by default the imaginary part is always 0. So if you give just one argument. It will be the real part, and by default the imaginary part will be 0. We can also perform some basic arithmetic operations on complex numbers. So for example, if we have two complex numbers, z1 equals 8 plus 7j, and z2 equals 4 plus 5j. We can add them using plus sign. We can subtract. We can also calculate the product and perform division. So divided by z2, and this will give us the result. So these are the basic arithmetic operations used with complex numbers. Please note that the floor division as well as the modulus operation cannot be used with complex numbers and will cause a type error. So if you try the floor division with complex numbers, it will not work and we will have a type error. This operation is not supported with this specific data type. So this is why it's important to know the different data types, even if Python doesn't ask you to declare the type of the variable when you create it, but it's important to know it, and this will give you more information on what operations can you perform on these variables. And the same for the remainder. It's not supported for complex numbers. And this makes sense since there isn't a clear way to determine what it means to round down, because complex numbers have both real and imaginary parts. I hope that you have enjoyed watching the video. If you'll have any questions or suggestions, please feel free to add a comment and I will do my best to reply if needed. See you in the next video where we're gonna see sequence types. Till then, take care.